Welcome to part 2 of the multi-part series, How to Analyze Training Data. This is Master of Nan. Just a quick recap of what went over last time, some key technologies and concepts. We looked at the challenge of finding and analyzing training data, web scraping with HTML tables, We covered web scraping HTML tables with Pandas. We went over some limited list and set operations, some data frame transformations. We covered very briefly the built-in map function of Python, and then also the read HTML, reset index, and transpose methods in Pandas. And before we move on, I just want to make a quick note. I didn't go over any development environment setup. I had links in the previous video in the comments to my own setup. However, this series is intended for someone who's already familiar with the basics of Python, NumPy, and Pandas. If you're not, it's probably not a real great starting point because I'm not going over basics. So there are a lot of other great tutorials out there about those things. This is for more intermediate developers. Okay, so moving on, at the end of our last video, we had created a list of first names with sex and then a list of last names with nothing else attached. Those lists were not the same size, they each had unique elements in them. So one thing I failed to do at the last part was to kind of display how to output those, but we'll do that again at the end of this video, so stay tuned for how to output files. So without further ado, let's hop right into it with our standard imports. This time we're going to import and actually use the OS module. We can import the regex module. We may or may not use it. We'll see how far we get today. Import NumPy as NP, import Pandas as PD, and then we're going to import the random function, which is one of those built-in ones here in Python. So assuming you've set up Jupyter Notebook in the standard way, you're going to have a working directory. So this is going to look different whether you're using a Mac, PC, or a Linux computer. Mostly the differences have to do with the divider. So like in PC you'll have the backslash, right? But on Mac and Linux you'll have the /, which is very handy. So before I keep going, I'm going to set my path variable using the OS get current working directory method. Right, and since I'm on my computer, I'm not going to print that, but what we will do immediately after that is we're going to say, we're going to have a new thing here called file list, and then we're going to use the OS list dir, this directory method, to show what's in our working directory. Okay, so you see I've got some Jupyter Notebook checkpoints, a few pictures, and then a couple of CSV files. So I'm going to use Pandas to pull in these CSV files. So let's pull in the first names one first. Now I could iterate through that list and pull the files. I'm not going to do that today. Because I don't have the patience. But what we'll do here is we will, so we've added our main path variable, right? And then we're going to, since I'm on Windows, I'm going to add a couple of backslashes, and then I'm going to add my CSV file. Now when I outputted them, I gave them a tab separated, so they were tab delineated CSVs. So here's my thing, we'll show 10, and voila. Here's our first little list of names. So we're just going to do the same thing for the last names. Whoops. And we can pretty much just copy this whole thing right here, change this to last, and then again, we'll check our work right here. Okay, so now we got this last names. So I did notice something after I had output the file with the last names, is that I had failed to get rid of a few total rows. So there are some rows that say total. So if we were to loop through this column, so we could say for value in df last names, we'll call it last name, so we'll reference that. If total in val, and then we're going to use the lower method to make sure it's lowercase to deal with any case issues. We're going to print the value. Otherwise, we're going to pass. Okay, all right. So there you see we've got four issues. So how I'm going to deal with this is so there's like a couple different ways. You could use regex to pull out all of the names and kind of exclude anything that doesn't have the term total in it. But probably easier would be to do this number. So we're going to change val to index, and then we're just going to call the index of this. And I almost always do the list method because I've run into some issues here and there with this. And then we're going to take this deal right here, and we're just going to change this to last name. So this should pull, oh, my bad. And there you go. Okay, so this should pull the name with the index and make it lower, and then I'm going to have it print the index of these lines here. So those are my indices. So we're going to say, we're going to call these bad indices right here, and we're just going to, oh, geez, apologies. We're just going to print those. Actually, take that back. We're going to make this a set, because these are all unique. So we'll say add, so do little set operations here. We're going to add those to the bad index set. And then we're going to check our work at the end. There we go. So now we've got our set. And let's do this. We will say new index equals list, because if you try to pass a set to an index, it's going to freak out. And then we'll take the set, which is df last names index to list. So we're changing it into list and then to a set. And we're going to subtract the bad index from said set. And then we're just going to check the length of this new index to make sure. Okay, so it's 328. So if we go back and we check the length of this index, 332. Okay, so it's -4. So then we're just going to save over our lovely last names file with our new index here. We take all columns, df last names. Now, as you can imagine, this is going to create something of an index issue for us if we ever try to loop through this, because it'll be missing the numbers 42, 83, 131, and 109. So what we're going to do instead is we're going to, you guessed it, reset the index. In place, true, drop, also true. Boom. Okay, so now we've got this lovely data frame that whose index ends at 327, which is what it should, for something that's ending at 328. I suppose I could have demonstrated what it looked like beforehand, but we're just gonna forget about that, okay? And then let's do a little bit of cleaning up. I'm gonna take this, put that right there. Take these two things, put them right here. Take these three things, put them right here. There we go. And then take this entire thing, we're going to copy it, just because I don't want to have any accidents. Delete, delete, delete. There we go. Just kind of clean it up a bit. Control A, copy, paste, delete. Okay, so now we've got our last names and our first names. And actually I'll take this again and put this up here. There we go. So this will just be for demonstration purposes, but we definitely need our path. And we're just going to say that this is the root directory for project, whatever that is, right? So we'll delete this, and now we've got a nice clean little break here. And then we'll make a few little annotations. So this will be file import, and this will be the section where we remove stuff from sets. Okay. Hit save. So now we have our pool of names, right? Last names and first names. So we're going to do just a little bit of sleuthing here. We're going to refamiliarize ourselves with the DF first names and see how long it is. So it's 1,037. And then I think we got 328 for DF last names. Whoops. Okay, there you go. So ideally, we want a good mix of names. Now, we don't necessarily want a cross product, right? So we don't want to take every single last name and match it with every single first name. But we do want quite a few unique names, right? And I'm sure that randomly we'll actually get some duplicate names in here. But let's just play with this a little bit, okay? So, we have our length here. Here's what we're going to do. We're going to create a new variable called fn1, first name's 1. And we're going to do some list comprehension to randomly choose names. And this is where the random module comes in. So from random, choose the random integer starting at 0. And then we want it to choose from the whole length and breadth of first names. So we're actually going to take this right here and then paste it in there. So that's going to choose a random number from each of the first names. And then we'll say for I in range, and then we're going to choose the length of that as well, right? Because we wanted to do it 1,037 times. Now, ostensibly, this could actually be a much larger number if you wanted to generate, say, like 2,000 names. So actually, let's do that. Let's take this out of here, and we're going to say we want 2,000 names, expecting that there's going to be duplicates, right? And we expect that this number is going to be 2,000 long. And if we actually look at this list, here you go, you've got this random, super random list of numbers going all the way down to whatever. Okay, Get rid of that. So now we want to generate matching last names, right, for this. So here we go. And you guessed it, last name 1 equals, and we're just going to copy this whole thing right here. Instead of first names, right here, it'll be last names. And then we're going to check our work just by kind of taking a, say, LN1, there we go, 2000. We'll take a look at what it looks like. There you go, lots of different numbers. The highest number here, though, should not be greater than 327. And we can check that, actually, by looking at using the NumPy max function. So sure enough, uh-oh, we got a problem. This has generated an index that we know if we look at df last names. Let's go through here, right? Df last names, tail, the last index is 327. So, right, we're going to go back and we're just going to say length of df last names -1. Okay? That was my bad. So we got to do that for each one. But instead of going through and doing this again here, we're going to do something else. Okay, so we're going to pull last name. Let's just look at like a random last name, Fisher. Okay, so we know that if we assign a number right here, we can index this last name column and just pull the name. So let's pull in this little index deal here. And we'll take this and put this right before the random, and then wrapped around this random statement, which gives us an integer. We'll do that. So this should actually give us our list of last names. So let's do that. So we know it's 2000. We just reran it. Let's take a look though. Boom. Now we've got all of these random last names from our random list. And then we're going to do the same thing up here, except with df first names, right? So df first names, first name. We'll index this, index that. There we go. Now for fn1, we're going to look at that. Boom, got this great stuff. Now we're going to combine these two lists together to give ourselves a list with last names and first names, since they're both the same length. We've got 2,000 of them. So, yeah, in a couple different ways you could do this. Let's just call this employee, right? And then this will be PD, concat. And now right here in this statement, we're actually going to have to wrap the list that we just did, right? So we want last name 1, and we're going to give it the column name of last name. There's our first data frame. Now we're going to create the second data frame with first name 1 and the column name of first name. Okay, and then since we got set our concat statement, we're going to choose the y-axis, so it's going to concatenate the columns, not the rows, like we did previously. And then we will double check our handiwork. Look at that. Awesome. So now that we have our last name and first name together, let's add the sex to this. So the easiest way to do this is to basically do a left join, if you're familiar with the SQL terminology, a left join from the DF first names table to the employee table. So let's do that, and let's call this one DF employees equals PD merge. Then we're going to do the left table, which is the employee table. And note that unlike the PD concat, which does concatenate on the index if you want it to, this one does not have the bracket right there. So it's literally just two tables right here. So PD merge, left table was employee, the other one is DF first names. And we tell it how. So in this case, we would like it to do a left join, and then we have to specify which column we want it to join on. So I want it to join on the first name column, since that is the common column, and we're going based off first name. Okay, and then we're going to check our work. Okay, so we have a slight hiccup here. There are 91 additional rows in this. So what does that tell you? Well, we know for a fact that the last name, DF last names, had all these unique values. But the first names, it turns out, after some investigation, while this was paused, had names that were ambiguously male or female, Pat, Chris, whatever, right? So those names, there's quite a few of those where there are names that were popular but then assigned to male or female. So because of that, we have all these extra lines. So we could go through and try to strike all of those, but you know what? We're just going to keep it for now because we have that variability in real life, so let's have the variability in our data set. Okay, now comes the fun part. This is where we get to find out, let's look at, while I'm talking about this, this is where we get to find out how many duplicates we have in this data set. So there are a couple different ways to do this, but probably, honestly, the easiest way would be to use the Pandas drop duplicates method. So we are going to select over here, and then we'll say drop underscore duplicates, and then we want to use in place equals true. And Pandas has an option to ignore certain columns. In this case, we really do want unique people. So you might have, if you see that first one up there, a Violet Aguirre. There could be a male Violet Aguirre or a female Violet Aguirre. And we want it to keep both because that's a unique person. So we are going to execute this cell. And now we're going to check our length again and see how many got dropped. Okay, so about 26 or so, 27. Not too bad. So we have 2,068 unique employees with which to build the rest of our database. But before we do that, we're going to assign some unique identifiers to these people. So we have the index over here, which could very well serve as, something, but typically these things are never sequential. So let's do something else. So let's create some random employee ID numbers and assign them to each employee. Actually, we've got to make sure that we don't have any duplicates. So let's do this. We'll go EID list equals random rand int for rand int with that. There we go. And let's place some random values in there. 6 for I in range let's say 5,000, right? And then we'll say length of PID list right there. So we got 5,000. So now we're going to do EID set, and then we're just going to neck our list down to a set, and we'll see how many unique values we have. Okay, so we have a great amount right here. So we're going to now assign some of these numbers. So we'll make the column named EID, and then we'll say I for I in range. Actually, we'll do a list, turn into a list, and then we will subset the list to go from the start of the list to, as many of the, well, actually we need that -1, right? So we'll just, there we go. Oh wait, no we don't. We'll take the other one. Okay. And then we will check our work, as always. See if it doesn't get angry at us. Okay, beautiful. So if we check out the length of our DF employees, EID, we should have 268, right, which you recall was our number from over here. So now we've got all these great things. And now we will output this to a file for use in the next video. So pretty easy to do this. I'm just going to say to CSV. And this is going to get interesting too, right? We're going to call this all employees CSV. Make sure it's Unicode, UTF-8, and then we're going to specify the separator, and we're going to make it tab delimited again because I think I'm getting a lot of mileage out of that one. Okay, so I have made my file and it looks good. So before we go, let's recap. So we learned how to reference the root directory that you're working in with your Jupyter Notebook, output a list of files from that directory, import with the Pandas read CSV method, do some fun indexing stuff right here, including reset index once again. We did a little bit of list comprehension, and we used the random randint method to generate a random list of names for ourselves. And then we used the PD concat method to concatenate some columns together, the PD merge to add some sexes to our peoples, the drop duplicates method to make sure those peoples were unique, and then some more list comprehension to generate a random list of employee IDs and assign those to our employees. And then we also lastly use the toCSV method to output the file to a CSV file for future use. Once again, this has been Master of NAN and How to Analyze Training Data Part 2. See you next time for the continuation of the series.